All right, the next rule that we have is the quotient rule. And it's worthwhile to compare and contrast the quotient rule with the product rule above. So first of all, notice that for the product rule, we are, the overall trend here is that we're differentiating one of the terms of the product while leaving all the other terms themselves untouched, undifferentiated, and then we just change who is being differentiated by adding them together. So for the triple product rule, we have three terms, where in each of the three terms of the sum, only one of the three terms of the product is being differentiated. So down here, we see that the top pretty much is the same as what we have for the product rule, but there is one big notable difference, and that is we have a minus sign in the middle. So because of the presence of this minus sign, the order here is very important. Whereas the product rule, I'm a creature of habit, so I always differentiate in this order: derivative of the first times the second left alone plus the first left alone times derivative of the second. You don't have to do that, though. I know plenty of people who, do f g prime plus f prime g. They do it in the opposite order. But that's fine, because at the end of the day, when you're adding together real numbers, the order of addition of real numbers doesn't matter. So that doesn't matter. But down here, when you're subtracting numbers, whether you do 2 minus 5 or 5 minus 2, you get something different. The one order you get 3, the other order you get -3. So the order here is important. The minus sign goes with the one where the denominator of your original quotient is being differentiated. So we basically have something pretty similar to the product rule with a minus sign. That's the main difference. And then here we have all divided by the bottom of the original fraction, your g, so to speak, squared. So like with the product rule, I use the terms first and second. For quotient rule, I use the language top and bottom a lot. So we have the derivative of the top times the bottom left alone minus the top left alone times derivative of the bottom, all over the bottom squared. So let's go ahead and give that a try with a couple with some examples here. So example 2. Take the derivative of the following functions using the product and or quotient rules where appropriate. So let's go ahead and get started here with part A. It's a quotient. So f prime of x, this will be, well, I always just start off making a big fraction. Sometimes the fraction bar is too short. More often it's too short than it is too long. So start off with a big fraction bar, derivative of the top, 2 times the bottom left alone, minus the top left alone times the derivative of the bottom. See, just short. All over the bottom squared. And that's it. Don't worry about distributing this -2x collecting like terms. If you had to go on and find the second and or possibly even third derivatives of this, then simplifying before you go to the next derivatives would be in your best interest. But for this problem, we're only stopping at the first derivative, so that is fine. So here, again, I'll do this in two different colors to symbolize two different methods here. The one method would just to go ahead and use the quotient rule. So if you go ahead and use the quotient rule, what you'd end up getting here is, again, draw your big fraction. Derivative of the top, 2x minus 6, times the bottom, 3x squared left alone, minus the entire top left alone, so x squared minus 6x plus 13, times the derivative of the bottom, which is 6x, all over the bottom, 3x squared, squared. So that's one way to do it. Or what you can do is take your, and this should be f prime. Excuse me, that's f prime. The second option here is, since this is something being divided by this one term, I can go ahead and split this fraction up into 3 smaller fractions. All right, so we could go ahead and first take f of x and rewrite it as x squared over 3x squared minus 6x over 3x squared plus 13 over 3x squared, and continue to simplify this until we got, let's see, a third minus 2x to the negative 1 plus 13 thirds x to the negative 2. And then when you go to differentiate this, you don't actually have quotient rule. You have simplified it algebraically, and you no longer have the need for quotient rule. So this is just 3 separate derivatives, all of which require power rule and nothing more complicated. So this would be 0 plus 2x to the negative 2 minus 26 thirds x to the negative 3. And it doesn't look like this expression we got here is the same as this expression up here, but they are. If you go through distributing, collecting like terms, dividing, and rewriting, this would, after some manipulation, turn into that. Okay, so this I really believe should be another example. This must have gotten messed up, so we'll just call this example 3. Pardon me. So for example 3, they give us a lot of information here, and then they ask us to determine the derivative of h when x is 2, given these two expressions for h. So for part A, we'll just dig in. We'll take the derivative, h prime of x. This would just be 5 times the derivative of f minus 4 times the derivative of g. And then we can just go ahead and plug in 2 for h. And let's see what we get. We'll have f prime of 2 minus 4g prime of 2. And simplifying this, what's f prime of 2? Well, that's negative 2. Minus 4 times g prime of 2, which is 7. If you go ahead and do all that arithmetic, we should get negative 38. For part B, we'll run through a similar process. We'll go ahead and use the quotient rule. So derivative of the top is 1 times the bottom left alone minus the top left alone times the derivative of the bottom. But notice, since the bottom is a product, we're going to have our good old product rule. Derivative of the first times the second left alone plus the first left alone times the derivative of the second, all over the bottom, which is f times g squared. So yes, you can see how this can get a little unruly for some of these derivatives. So if we go through all of this, plugging in x equals 2, which takes a little bit of time just to write it all out. So if you go ahead and make all those replacements, which is a little bit crazy, so I won't show all that in the video, but I will say that we're going to go ahead and replace f of 2 with negative 3. So that means this f of 2 is a negative 3, and this f of 2 is a negative 3. What's g of 2? G of 2 is 4, so this is a 4, this is a 4, this is a 4, so on and so forth. So if we go ahead and do all of that, we should get, after simplifying and reducing the fraction, 2370 seconds.